Now we're going to take a look at equations where our variable is part of an absolute value expression. And we're going to look at the steps necessary to get that variable out of that absolute value. But before we do that, we want to make sure we have a solid idea of what absolute value actually represents. So remember that absolute value represents a number's distance from zero. And when we talk about distance, distance is always positive. So if we have a negative value inside absolute value, when I evaluate it, it's actually going to end up being positive. If I look at this very basic equation, we know that x is a number that is 7 steps from 0. So if I go 7 from 0 in the positive direction, we end up at positive 7. But if I go 7 from 0 in the negative direction, we end up at negative 7. So we could say that x is going to be positive 7, or x is going to be negative 7. So a majority of the time that we solve an absolute value equation, we're actually going to get two solutions. And we're going to still write these in our brackets, with the smaller solution coming first, and then the greater solution. If we look at this one, we know that 2 times some number has a distance from 10. So this means that the whole inside is either going to be 10 or negative 10. Because if I take the absolute value of either one of those, I'm going to get 10. So we write two equations. 2x could be 10, or 2x could be negative 10. Because we know that those are both 10 units away from 0. And then we just solve each of these equations simultaneously. So we divide both sides by 2, we get x equals 5, and here we get x equals negative 5. So I'll put these in, and that's our answer. For absolute value, because you get two solutions, we're usually not going to ask you to check these, just to save you some time. Great. If we look at this one, we know that the whole inside has to be 20 units from 0, so it's either equal to 20 or negative 20. So we're going to write two equations. X plus 7 equals 20, or x plus 7 equals negative 20. We solve each of these independently, so x equals 13, and x equals negative 27. Put that together in our brackets for our solution set. Now, anytime we have anything outside the absolute value, we need to move that over to the other side of the equal sign, because we're only allowed to split up the equation once the absolute value has been isolated and is by itself. So I'm going to start this one by moving that 3 to the other side with subtraction. So now my new equation is x plus 4 equals 5. So we know that this expression on the inside has to be equal to 5 or negative 5, because it has an absolute value of 5. So x plus 4 could be equal to 5, or x plus 4 could be equal to negative 5. We have to write these two separate equations, because if I just write this, then I start doing operations outside the absolute value, which we can't do. So we can't split it like this. We always have to split it into the two equations without the absolute value symbol. So here we're going to get x equals negative 1 and x equals negative 9. Let me go ahead and put that into our solution set. Okay, go ahead and pause the video and try this one on the left. Alright, so when we solve this one, we first have to isolate that absolute value, which we do by multiplying both sides of the equation by 2. Make sure you also multiply the 5 by 2, because otherwise you're no longer maintaining that balance. Then we know that our piece inside the absolute value has to be equal to 10 or negative 10. We write our two equations, and we get a solution of negative 18 and 2. Go ahead and try the next one. So we have to start off by isolating our absolute value again. And this is the same as solving the equation negative 7 plus 3x equals negative 1. We always start by moving the constant, and then we get rid of the coefficient. Once we do that, we know that the inside has to be equal to 2 or negative 2. So we write two equations and solve, and we get negative 3 and negative 1 for our solutions. Okay, now something to think about. If our absolute value ends up equal to a negative, can that be possible? Remember that absolute value is always a distance, so we never have negative distance. We would never say, I drove negative 27 miles, or I walked negative 5.2 kilometers. So distance is always going to be positive. So if we get to a step like this is going to mean no solution. But the absolute value has to be isolated before we can do that. So for this one, for example, I have this negative sign right here, but my absolute value has all this stuff with it, so I can't say no solution yet. I start by moving my constant. So we have the absolute value of 7x minus 1 times 5, and that's equal to negative 40. Then we divide by 5, so the absolute value of 7x minus 1 equals negative 8. And here I have that negative. This is another contradiction. So this is our no solution. And we put our empty brackets because we don't have an answer. Go ahead and try the other one on your own. When we solve this one, even though we start off with a negative, this actually has a solution that we can get. As soon as I add the 8 to both sides, we end up with a positive, so this one works. We know that our expression inside the absolute value has to be equal to 3 or negative 3. When we solve, we get 0 and 6 for our answers.